As we're looking at midpoint, you add your x's, divide them by 2. You add your y's, divide them by 2, and you're going to get a new point that's right in between the two. Now notice, do I have any graphs on this?
No.
Let's just sketch this just to ballpark it. 3, 5. 6, negative 1. Draw your line, make your x. Our target is that x. Now midpoint is always labeled M as a point. Just midpoint M. So let's try to find out what this midpoint is. 3 plus 6 over 2, comma, 5 plus negative 1 over 2. 4.5, because that's 9 over 2. Okay, 4.5 and 2. How close was I? Is it about 4.5 and 2? Now, considering my sketch is really rough, which is a better way to find the midpoint, algebraically or graphically? Algebraically, I would think. Add them together, cut them in half. Is this pretty easy? All right, let's look down. The midpoint, when I do a little subscript like that, why am I doing that? What is my purpose? I'm telling you it's the midpoint of what?
Point B, C.
Yeah, of B and C. So here we go. Negative 4, what am I going to add to it? 0 over 2, comma, 10 plus negative 2 over 2. On your homework, this is the work I want to see. I want to see this part, and then you can go write your answer. So the midpoint of BC, help me here. Luke did the last one. Someone else do this one.
Negative.
Drew?
Negative 2.
Negative 2, comma,
8. No,
4. You had 8 was right because you were going to divide by 2. So negative 2, comma 4. Is that right?
No, it's 9.
10 plus negative 2 is 8. 8 over 2 is 4.
I don't know how that is.
Is it likely you might get an odd number in a decimal? That's a pretty high likelihood. They might turn out even, they might turn out odd. All right, flipper. I love applications. Given a circle with the center point C, if the diameter lies on the line segment A, negative 2, 6, and B, 6, negative 4, find the center of the circle. Well, I guess to do this, we better draw it. Negative 2, 6. 1, 2, 3, 4, 5, 6. Justin, what quadrant am I in? Reviewing here. 2. Okay, other point. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. There's B. Somebody else, what quadrant am I in? 4. All right, try to draw a circle. And now draw this line. What is this line representing? What do they tell us? It's the what? What is that line? It's the diameter. Where does the diameter go through? The middle, right? So the center of this diagonal, the center of the circle, is right about there. How does the center of a diameter relate to the idea of midpoint? Is it the same? So let's find the midpoint. Who can set it up for me? Jelon, go ahead.
Negative 2 plus 6.
Comma.
And 6 plus negative 1.
Keep going.
4 over 2. 2
So my answer?
2 plus 1.
Let's see how close we were. 2, comma 1. So that is point C. if I asked you, interesting question, taking it back to yesterday, what the radius of this circle was, would you be able to find the radius? Think back to yesterday. How do you find the radius?
Do something plus pi or something.
What did we do yesterday?
You just add it up.
What idea did we talk about yesterday? Look back.
Distance.
We talked about distance, right? Would it be possible to find this distance? Remember the distance formula? Do a little review here. The distance is the square root of the change in x squared plus the change in y squared. Could you find that distance now that you know A and C? Yeah. So realize, guys, what we learned could be applied to a lot of figures to finding distance and finding midpoints and finding radius and finding lengths of diameters and things like that. So all that is very, very possible. All right, looking down here at the bottom. Given an endpoint of a line segment F, good morning Sam, and the midpoint M, find the other endpoint. Let me sketch this so you get a visual of what we're trying to do. 1, 2, 1, 2, 3, 4, 5. That's the point E. Midpoint, 6. -1. Okay? I have E and I have M. Put an X where you think F is. Put an X on the graph where you think F is. Find F. Put an X where you think that is. Where am I going? Someone tell me my pen where to go.
Down. Over to the right. Down. Over to the right. Right back up.
About here?
Yeah.
Ballpark, is that about F? If it is, what should M be? Right in the middle? How could I figure it out?
You add I and E and C.
Here's E, here's M, here's F. Let me show you how you think through this. Guys, look at 2 and 6. How far from 2 to 6? How far do you think it should be from M to F? Should it be 4 more? So if that's 4, then that should be 4. So what should this F point be? 10. Okay, Luke's got this first one for us. Somebody else, how far from 6 to -1?
It's 5.
Sorry, 5 to -1.
It'd be -7.
Going down how far? 6. So Zach would go down 6 more to -7. How would you check these? Let's add them. What's 2 plus 6?
8.
2 plus, I'm sorry, you answered my question. What's 2 plus 10?
12.
12 divided by 2? 6. What's 5 plus -7? -2 divided by 2? So does the midpoint idea still work? Yeah. What just happened? What do you mean? How we got F? Okay, you understand my point, my graph? When I was just trying to ballpark where F is, I was saying, okay, about how far is that? Okay, go about the same distance to ballpark it on the graph. But then algebraically we said from 2 to 6 is going up 4. So if it truly is a midpoint, we should go up 4 more. From 5 to -1 is going down 6. So if this is truly a midpoint, if we go down 6 more, we'll get to -7. So you should be able to either find an endpoint or a midpoint depending on what they give you. Which is easier, the midpoint or the endpoint? Should be pretty straightforward. So